Okay, we've been talking about light and specifically color the last couple of class periods. And well, this is the color wheel, and you can see where red and blue meet, it makes magenta. Where blue and green meet, it makes cyan. And where red and green meet, it makes yellow. And where all three of the primary red, blue, green meet, it makes white. Okay? And it's a little bit different than art class. The three primary additive colors of light are red, green, and blue. You don't need any other colors, just red, green, and blue, and you can make any other color. The subtractive secondary colors are your art primary colors. When you mix all of them together, you get white. When you mix just red and green together, they make yellow. Blue and green light together make cyan. Red and blue light together produce magenta. So we really have the complementary secondary color white, which is when you mix colors to make white, they are complementary. And then the three secondary colors of yellow, cyan, and magenta. On your notes, if you want to go ahead and draw the color wheel, you can pause it here and fill it in. And there's two main ways that we deal with color. One is by reflection, the other is by transmission. First one by reflection is that things are the color that they are because of the light that they reflect. If white light is available, then that means red, green, and blue light are all available. And this red bar here is red to the observer because it absorbs blue and green and reflects red. So as long as red light is available, this object will appear red. This time there's a cyan bar. If white light is available, that means red, blue, and green light are available. This cyan object would absorb red and reflect blue and green. When your brain it gets a signal that blue and green light frequencies are available, it creates cyan. So on your notes there are several questions. Red objects reflect red and absorb green and blue. Yellow objects reflect red and green and absorb blue. If you'll keep going back to the color wheel, you'll see with the mixing, you'll see that yellow is a combination of red and green. Okay, and then as you pass down, I think there are 11 questions there about reflection and transmission. You just have to keep in mind that things are the color of the light that they reflect. So red objects reflect red and absorb blue and green. Yellow objects reflect yellow and absorb blue. And reflecting yellow means it's reflecting red and green. Black objects reflect nothing, they absorb all colors. White objects reflect all colors and absorb nothing. Cyan objects reflect blue and green. And when your eyes pick up blue and green, they send signals to your brain, and your brain makes up cyan. And cyan objects absorb red light. So go ahead and finish out the note sheet with the other questions, and we'll move on to colors by transmission. So there's still absorption, but instead of reflecting, transparent objects let light pass through. But the same color rules apply. Like this is a cyan colored filter. As long as all colors are available, the cyan filter would absorb red, let blue and green pass, and blue and green, your brain turns into cyan. Here we have some overlap filters, or not overlap yet, sorry. If a red filter has all colors of light available to it, it allows red to pass and absorbs blue and green. Again, if all colors are available, blue filters absorb red and green and let blue pass. Yellow filters absorb blue but let red and green pass. Red and green make yellow. A magenta filter would let blue and red pass but absorb green light. Now for overlapping filters, and we still have all light available, well, up top, the red filter would let red light pass and absorb the blue and the green. The blue filter will only let blue light pass, but there's no blue light available, only red, so the person sees nothing. Down at the bottom, the yellow filter, which is a combination of red and green, it lets red and green light pass and absorbs the blue. And then the red and green runs into a magenta filter, which absorbs green and lets the red pass. So the person at top sees nothing, the person at the bottom sees red. And again, it's the same whether it's reflection or refraction or transmission. The light has to be available to be